So we continue with question 2 of story sheet 7. It was requested by someone who requested 1, 2, 3. So we are on 2 now. So if you want to request any tutorial sheet question or any other question from anywhere, as long as it's a problem in any of the sciences, you can WhatsApp the picture of the question to 0978957975. So let me introduce myself, David. See you, Banda. So aka the universal data boy. So today we'll be looking at tutorial sheet 7. Tutorial sheet 7. Tutorial sheet 7. Question 2. A. We will begin with A, then we'll go to B. So there we can write there A plus number Sada, which you can also use to refer me to. So question 2a says calculate the resistance per unit area of a 22 gauge nichrome wire of radius 0.321 millimeters. And then B says if a potential difference of 10.0 is maintained across a 1.00 meter length of the nichrome wire, what is the current in the wire? So to start the question, we have to know what we are being told to find. If you don't know what you're looking for, you will be unable to find it. So what we're being told to find is not the resistance, is not the length, but is the resistance per unit of length. So that's resistance over length. So they want to know over this length, what's the resistance? So we don't really have a formula that gives us the resistance over the length, but we have a formula that relates resistance to length. So what we can do is basically look at that formula. It is R is equal to rho L over A. Rho is the resistivity, L is the length, and then A is the area. So now we can make this subject of the formula from this equation by dividing both sides by L, which will in the end will multiply by 1 over L, by 1 over L. So now these L's will cancel, and then we'll have R over L being equal to, so this is our symbolic answer. Then from here we can find the resistance per unit area. Are you trying to get what I'm trying to say? I hope you are. So from here now, we know we have the resistivity, and then we also have the area. So what we can do here, we are not given the area per se, but we are given the radius. So now we can collect our data. So now rho is equal to 150 times 10 to the power negative 8, and it's in ohms meter. Then the radius we're given is 0.321, and then it's in millimeters. So to take it to meters, you must multiply times the negative exponent of negative 3. Yeah, so times 10 to the power negative 3 meters, and thus we have converted. We don't have to go to various conversion factors or do anything complex right here. All we have to do is just multiply it with 10 to the power negative 3. So then we have our area. Hey, my pen is done. So now we have our area being equal to pi r squared. That's the area of a sphere, of a cross section. So now from here we have our radius, so definitely we know our area because pi is a constant. So now we plug in the values there. They go to rho pi r squared. So now here we just have to plug in the values, and then we'll definitely get the resistance over the unit of length. So now this is 150 times 10 to the power negative 8 ohms meter over pi. The radius is 0.321 times 10 to the power negative 3 or to the power 2. So now the resistance over the length is, get our calculator, then we have 150 exponent like 8. Okay, let's start with the denominator. So we have pi being multiplied by 0.312 exponent negative 3 to the power 2. So we have that as our answer. Then we divide it by 150 exponent negative 8 divided by answer. There's a mistake somewhere. So 150, let's start with the denominator again. Pi multiplied by 0.312 0.321 exponent negative 3 to the power 2. So we have that as our answer. Then we divide 150 exponent negative 8 divided by this answer. So we'll be having 4.6. So 4.6, 4.63, it goes all the way, but then we look at the significant figures that we've been given in the equation, and then we can end here. So this one for the SI units, this meter cancels with 1 meter here, because here we have 2 meters. When you multiply these two, when you multiply this meter twice, we have meters squared, and then here we have just a meter, so the meter cancels with the meter squared, leaving a meter in the denominator, and then the ohms, we just have the ohms there, then it will be ohms per meter. I hope you're trying to get what I'm trying to say. So these are the SI units, and then the SI units are reflecting or coinciding with what we have here, because this is resistance per unit of length, resistance per unit of length, ohms per meter, and thus this is simply our answer. So now let's go to B. So now in part B, we can start with V as a function of I, because from here we can get the equation for resistance, where you can get the equation when you make I the subject of the formula. So we divide both sides by R, then we have our I being equal to V over R. Now remember, we have R per unit of length, we have R per 1 meter, and then in the question we're being told, it says maintained on a 1 meter length of the nichrome wire. So definitely we know that this figure which we got here is the resistance per unit of length. So let's say we had let's say if the wire was longer, for example, if it was twice as long as this one, it could have been half this figure. If we were not given 1 meter in the question, if we're given, let's say 0.5, this figure could have been twice, which is 9.2, I think. So now we know the resistance. The same resistance is the one which you get. So we are now having 10 as our voltage over 4.6 ohms. So now our I is just equal to 2.2 when you calculate on the calculator amps. So now that's all for part B. So part 3 will be solved in the next video. Just stay tuned. Make sure you subscribe to the channel so that you don't miss out on anything, and also please give me feedback in the comments, in the like section, and also through the WhatsApp number 0978 957 975. That's all from David Banda, the A+ ambassador, or the Universal Data Boy. From the Deal Dealers, it's bye bye. A luta continua, and together we can.